DNS stands for Domain Name System, and it is a process that allows us to type in the name of a server and have that server behind the scenes automatically resolve to an IP address. So all we have to remember when we're browsing the internet is to type in www.professormesser.com, and behind the scenes magically there's a process that occurs that now your machine knows the IP address of professormesser.com and it's able to communicate directly to it. And it's this DNS, this domain name system, that allows that automatic process to occur. DNS is something we call hierarchical, which means that there are a series of servers set up from a top layer, a second layer, a third layer, and so on. DNS is also something called a distributed database. There's no single DNS server. There are thousands and thousands and thousands of DNS servers out there on the internet that are being used, and we're able to now separate out which each one of those servers is responsible for. For instance, there are 13 at the highest level, the root servers of the internet. There are 13 clusters of these servers out there. There are also these things called top-level domains. We'll look at this in a moment, but there are 20 top-level domains that are out there on the internet, so you can think at least 20 different clusters of DNS servers that manage those, and 248 country code top-level domains. And then from there, it even goes further down in this hierarchical list. So when we start looking at the structure of the internet, we can see that even if one of the servers goes down, we have other servers that are able to keep everything running. And even if we lose a little bit of connectivity to the internet, it's not going to be an all or nothing scenario. And it's because this database of names is completely distributed throughout the entire internet. If we were to put the internet in a hierarchy in a graphical form, this is what it would look like. At the very top is your root level domain. And you can see I've just put a period here so you can see that that's the very top of the internet. Whenever we're communicating, say, to www.professormesser.com, that .com is what we call a top-level domain. And there are many, many different top-level domains. This is just a few of them. The .com is for commercialenterprises.net, .edu for education, .org for organizations, .mil for military, and so on. And all of those top-level domains have their own set of DNS servers that we would need to reference. Now, if we're trying to communicate to professormesser.com, then you would need to go to Professor Messer right here from the .com. It's not in the .net, the .edu, or the .org domains. It's a hierarchy. So first is the .com. Secondly would be Professor Messer. And of course, we haven't got to the web server at Professor Messer. There are a number of different servers at Professor Messer. You've got a www.professormesser.com. I also have live.professormesser.com, and there's mail.professormesser.com. But let's say in my organization, I also have an east and a west that I use to separate out my organization. And in the east, there might be other machines out there. One would be the trade.east.professormesser.com. One might be katie.east.professormesser.com. There might also be a west part of my organization. So there may be a computer at that side called the ethan.west.professormesser.com device, and so on and so forth. And it's this hierarchy that not only allows us to organize things properly, but I can have separate DNS servers that handle just the east, or that handle just Professor Messer, or a combination of both of those. And I can configure them in any way that I'd like. If we were to view the professormesser.com domain then in a graphical form, it might look something like this. This large circle on the outside is professormesser.com, and inside that, I might have a fully qualified domain name for my web server, and that fully qualified domain name is www.professormesser.com. So we're putting the entire view on here. If we looked at this individual server, the server might be called www, but because it's in the professormesser.com domain, we would call this fully qualified domain name as all of those put together. But of course, I might have an east side. Here's my east.professormesser.com domain, and there may be a device whose fully qualified domain name is katie.east.professormesser.com. And a similar thing for the west. I have a west.professormesser.com domain, and there's a fully qualified domain name for this device, which is ethan.west.professormesser.com. Whenever you're asking for the name of a server, you're not actively typing in, please give me the IP address associated with that server. You're simply typing in the server name or the website name. And behind the scenes, DNS is handling the process of resolving that name to an IP address. If we were to look at our computer, there's some software running on our computer, maybe even in the applications that we use, called the resolver. And that's what the resolver does, is make sure that it goes and makes those requests for those IP addresses. The resolver looks first in the file that may be on your computer called the host file. Prior to there even being domain name services out there, everybody simply had a host file in all of their computers, and anytime you wanted to talk to a device, your machine looked in that host file to see what IP address was associated with that host name. Well, obviously, we can't do that on the internet now. It's certainly too large to do that, but host files are still there. So the resolver will first look at the files that are local on our computer and the list of that host file. And if it's not there, it's going to send a request out to a local name server. And maybe that local name server knows how to get to ProfessorMesser.com. And if anybody had done a request previously to that website, in fact, it may be cached out here on this local name server. But we're going to assume for this exercise that nothing is cached. This is the very first time that anybody on our site has ever requested this particular web server. Now, this local name server has a list of all of the root servers that are out there on the internet. And since it doesn't know how to get to ProfessorMesser.com, it makes a request to the root server to say, how do I even begin resolving www.ProfessorMesser.com? And the root server responds back and says, you're going to need to talk to the .com name server. So let me give you the IP address for the .com name server, and you can go talk to that device. The local name server then says, great, I'm going to ask the same thing of .com. Do you know how to get to ProfessorMesser.com? And that .com server is going to say, Professor Messer, yes, I have it right here. You're going to need to talk to the very specific name server for Professor Messer. Here's its IP address. And now we're getting further and further down the hierarchy. Finally, the local name server talks to the ProfessorMesser.com name server and says, do you know how to get to www.ProfessorMesser.com? And my name server certainly knows how to do that and says, here's the IP address you need to be able to access that web server. At that point, it's cached in the name server, and the answer is sent back to your local machine. And finally, it can communicate directly to the ProfessorMesser.com name server. Now, although this seems like that was a lot to have happen, it actually occurs in a very short period of time. And that's why the very first time you might type in a name server, it might take half a second before you see that finally go. And every time after that, it's very, very quick. That's because the first time it goes through this entire process. The second time, it only has to access the cache that might be in that local device. But this occurs every single time you need that. And it's that resolution process that's now cached that makes it that much faster for everyone. So this won't happen every single time, but if you ever need to access this and it's not in the cache, it's going to follow this process every time you need to resolve a name to an IP address.